So I'm solving the slit width equation problem from problem set number 5. So for part A, to figure out the spacing between the slits, I used this equation, which we are given in lab 3, where x is the distance between the first central maxima and the second central maxima, or any central maxima, and then d is the distance to the screen. So we're given the distance between the maximas, which is the tick marks on the figure, and then we are also given the distance to the screen. And I converted all of these to centimeters just to have them all in the same unit. And so plugging in 1.5 for x and 217 for d, and you take the arctan of this to get theta. And when you solve for theta, it is 0.396 degrees. So then this is the theta that you'll use for the space between the slit equation, which we're also given in lab 3, which is this equation right here, where m is like first, second, third, maxima, minima, and lambda is the wavelength, and d is the slit width. So you plug in this theta, and then you're given the wavelength right here, and m is 1 because this is for the first, between the first and the central maxima. So after you plug in all of these values, you will have this. So then you multiply both sides by d and divide by sine of 0.396. And when you do that, you get that d equals 7.52 times 10 to the negative 3 centimeters, which is the same as 7.52 times 10 to the negative 5 meters, which is what the answer is in long kappa. And so then for part B, you are finding the space, or sorry, the slit width. And so you're using a form of this equation again, and I got this from the labs as well. And then with some rearranging. Oops, sorry. This is the equation that you get, where A is the slit width, lambda is again the wavelength, D is again the distance to the screen, and Y is the distance between the tick marks on the figure. So when you plug in all that you are given, well, Y is the distance between the tick marks on the figure, and also because you're solving for this and the fifth maxima is the one that is missing, it's the tick marks on the figure times 5. So plugging in, I left this in meter form to make my answer easier after realizing that the first answer was going to be that they wanted the answer in meters. So plugging in what we are given, we get this. and that gives us an A of 1.535 times 10 to the negative 5 meters, which is the answer in long kappa. And then for the last part, you're finding the new distance between the peaks if the slit separation increases by 3. So the way that I solved this was, if you look at this equation here, where this is the spacing between the slits, D, if the slit separation is increasing by 3D, or by 3, that would mean that that is 3D. So the only way to make this equation balanced is to divide the other side by 3. So you know that sine theta has to be decreasing by a factor of 3 if the slit separation is increasing by a factor of 3. And because theta is so small, this is the same as saying that tangent theta will also be decreasing by a factor of 3. And so if this is decreasing by a factor of 3, that means that the only way to make this equation balanced again is to multiply the distance between the tick marks, or yes, by 3. So that means that the new distance between the tick marks will actually be 1.5 divided by 3.